Hey everyone, this is another video on section 2.10, market failure, market power, and today we're going to be looking at revenue and cost. So first we'll get our heads around the terminology. Total revenue, nothing new. Price of the good times the quantity sold. Average revenue is just the revenue per unit sold, so total revenue divided by quantity. And marginal revenue, this is the additional revenue from selling one more unit. And this is how we calculate it. Change in total revenue divided by change in quantity. When we examine the revenue of firms, what we've got to realize at this point is that there are two types of market. One where the firm is a price taker and has no influence on price, and one where the firm is a large enough player in the market that it can influence the product price. We'll go into a bit more depth on market structures. We've already touched on it a bit. We'll go into more later on. Firstly, we're going to do some calculations. We're looking at a firm with no price control. As you can see, the price doesn't change. They can't control it. Pause now, draw up this table and calculate total revenue, marginal revenue, and average revenue. Okay, I am sure you got this. If it doesn't look like this, you'd want to go back and check your work. Now that we have all this beautiful data, I want you to plot some graphs. So I want you to plot the total revenue, average revenue, and marginal revenue curve on a diagram. So ideally, you can do it on like a maths pad. That'll probably work best. But all on these three curves, all on the same graph will work quite well. Okay, should not have had too much trouble with this. Total revenue curve will be upward sloping like so, and average revenue and marginal revenue that's just flat. Right, they stay at $10. So that's super easy. No problems there, I am sure. Now we'll look at a firm that has some price control. Okay. You'll notice that as they supply more, the price comes down. This shouldn't be too surprising, as we've learned about economies of scale. And also, the less scarcity of a good, the lower price you can charge. Again, we need to fill out this table, so calculate away and work out the total revenue, marginal revenue, and average revenue at each price level. Okay, pause and do that. Okay, this was a little harder than before, but I'm sure you still got there. Check to see if you're correct. This time, due to the scale we've got here, let's draw them on two separate graphs. So total revenue on one graph with revenue up to 100 on the y-axis, and marginal revenue and average revenue, we'll do that on a smaller scale graph. So just with revenue up to 16, that will do. Okay, so if we've had some time to draw that, if you've paused, here's what it will look like. Here's the total revenue curve when the firm has some price control. It starts out looking like before, just upward sloping, but the total revenue grows slower and slower until it stops growing when quantity hits 7, and then even falls when quantity hits 9. Okay, the marginal and average revenue curves, they also look quite a bit different. So they diverge in this example. Marginal revenue goes negative. That's not a mistake. That is what this curve is always going to look like, the marginal revenue curve, when a firm has some price control. What we can see is that when marginal revenue hits equals 0, this is also the peak. Quantity of 8, it's also the peak of the total revenue curve. And we also know that total revenue will never get down to 0, as this is impossible. Now, something that you may have noticed is that average revenue is just equal to the price. So the AR curve here is the demand curve for that firm. Okay, how do we know the average revenue equals price? We can do a little quick thing here. total revenue equals price times quantity, and average revenue equals total revenue divided by quantity. So we just do some substitution here. Eventually we get to the idea that average revenue equals price. Okay, we'll be moving on to look at costs now. You can even see what I've done up there. I reckon that's pretty good. In this section of the course, we're going to be talking a little bit about the short run and the long run. So here is as good a time as any to make that distinction. The short run is the period of time where one or more factors of production are fixed. And the long run is where all factors can be changed. Unfortunately, we can't simplify it and say that the long run is, say, 2 years or more and the short run is less than 2 years. It doesn't work that way. In the case of, say, a nuclear power plant, to build another reactor, that might take many years. That's its long run. Could be decades even, I believe. Compare this to, say, a pizza place, my local pizza place. It could change its entire operation well within a year. So its long run is very short. So it's not a distinct period of time. That's what the point we need to get around. Okay, we're also going to break down the word costs here. Generally, when thinking of costs for a firm, your average person will think about explicit costs, those which involve a payment, so think wages or buying inputs. But those of us who have studied economics, we're better than average people. We know that there are also opportunity costs involved. For example, these are implicit costs. We'll call them implicit costs here as well. An example of this is the salary that a business owner could have earned in another job, but instead they've been working for the business. So they have an opportunity cost, what else they could be doing with their time to make money. And they also have an opportunity cost of what else they could be doing with their money to make money. So you could invest $1 million starting up a business, or you could sit that money in the bank. So that is a real cost. You are foregoing the opportunity to earn that interest in the bank, right? So what we say is economic costs equal explicit costs plus implicit costs. Okay, and from this point on in the course, whenever we talk about costs, we have to assume that we mean economic costs, all right? That all economic costs are included, so both the explicit and the implicit costs. So from here, there's no caveat that, oh yeah, there's also opportunity costs. We assume it's included from this point, okay? All right. Here's a couple of equations. We saw similar for revenue. We'll need these soon, so make sure you get these down. Soon has now arrived. So let's draw up this table and we're going to calculate average cost and marginal cost. So I'll let you pause now and do that. All right, well done. I know you certainly got this data. Now, if we were to plot this data out, we would get our two curves looking similar to this. You're going to be drawing a lot of marginal cost and average cost curves. And there's a detail that we need to get right when we draw this. And that is that the marginal cost curve will always pass through the bottom of the average cost curve. So see how that does there? I'm not sure that's absolutely perfect, but that's close enough. You just can't draw the MC curve going through, say, over here or over here. That won't work. It'll look really wrong to an economics teacher who was marking it. Now, why does it always have to pass through the bottom? There is, if we just think of a simple example, we can get there. So let's say that your average test score, your average mark is 80%. If your next test score, so your average 80, if your next test score, so your marginal test score is below 80, then your average must be coming down, right? If your average is 80 and then your next one is lower, that's going to drag down that average. So if marginal cost is below average cost, it will drag down average cost. Likewise, if your next test score, your marginal test score, is above the average, that's going to drag the average up. So what we need to understand, marginal cost of one extra unit is below average cost. It brings AC down. If MC of extra unit is above AC, it raises AC. So therefore, it has to pass through the bottom. You won't be asked to explain that, but that's how it is. Now, if we continue to look closely at these curves, here we've got the average cost curve. We see that it's a U shape, sort of. The U shape in the long run is due to economies of scale and diseconomies of scale. We've talked about this a little bit throughout the course, mainly economies of scale. How does that work? So economies of scale occur when average costs decrease as a firm increases its output. So here, output's increasing, average cost is decreasing, right? That happens for a number of reasons. Firstly, in a large operation, there tends to be a specialization of labor. Each employee specializes in one task and becomes proficient. That increases efficiency and lowers average cost. So think of a production line. That's sort of how it works. A larger firm can also spread their costs among far more units. So think of these two cola firms. They both want to pay for a billboard advertising their drink. Coke can spread this cost over 1 million bottles of Coke sold. Bourne Backyard Cola, however, they have to spread this cost over only a few thousand bottles sold. So the effect on average cost is much smaller on Coca-Cola than it is on Bourne Backyard Cola. So Coca-Cola, because they operate on such a large scale, they can spread their costs so that the cost per bottle of that advertising is just tiny. Another factor is buying power. A large firm will buy a large amount of inputs. They can therefore negotiate favorable rates on these. A small firm does not have the power to do the same. Financing costs can often be lower for a large firm. Think of two cola producers, Coke and Bourne Backyard Cola Company. Who would a bank rather lend money to? It's going to be Coca-Cola, right? As a much larger operation, they have much less risk of defaulting on their loans, and therefore the bank is likely to offer them a lower interest rate. So it's another advantage of being big, another saving of being big. All right, diseconomies of scale. So the upward sloping section of the cost curve, that is this bit, that is explained by diseconomies of scale. This is when average costs rise as a firm produces more output. One reason for this is a lack of organizational control. Management is no longer able to monitor everything that happens as a firm gets larger. So think of, the founder of a business. They can't have everything done their way. Whereas when it was 10 people, yes, they could. When it's 1,000 people, you can't see what everyone's doing. Inefficiencies occur, average costs will rise. There's even a TV show made about this, Undercover Boss. We'll watch a clip in class to help get our heads around it. And related to this organizational control idea is the communication difficulties that can happen. In a large firm, information flows through so many channels that messages can get distorted, inefficiencies occur, and average costs rise. Okay, that is revenues and costs. We'll need to take the notes and sort ourselves out. All right, thank you.